Here's a relatively easy question. It says an object of mass m equals 1.00 kilograms is observed to have an acceleration with a magnitude of 10 meters per second squared in the direction 60 degrees east of north. When it gives you the figure, the force F2 acting on the object has a magnitude of 5 newtons and is directed north. Determine the magnitude and direction of the other horizontal force acting on the object. The first thing you could do is make a triangle showing the forces. Notice how it'll be in the same direction as the acceleration, because the acceleration is proportional to the force, and the force travels in the same direction as the acceleration. So then we could quickly write F1 is equal to max, because F1 is the horizontal force, F2 is the vertical force in the y direction, is equal to may. We could easily find a sub y by dividing F2 by the mass, and that'll give us 5 meters per second squared. Remembering that the Newton is equal to kilograms times meters over second squared, and therefore dividing force by mass will give us meters per second squared. So now for my acceleration triangle, I'm going to plug in the numbers that we know, 5 and 10, and then we could simply solve for ax. Delete this part over here so I can make room. I could use the Pythagorean theorem to find a sub x. A squared is equal to ax squared plus ay squared. Solving for ax will give us ax is equal to the square root of a squared minus ay squared. Quickly find that, plug that into your calculator. You'll see that we get a sub x is equal to 8.66 meters per second squared. You could also use trigonometry to find it, seeing that a sub x is equal to a times cosine 30. And then if we plug that into our calculator or substitute the numbers, we have 10 cosine 30 degrees. And using our calculator, we'll see that we'll get the same exact answer as the Pythagorean theorem. And then we could substitute that into our acceleration triangle. Later, we could find the force, the horizontal force, using the mass times the acceleration. We have 1 kilogram times 8.66 meters per second squared. Multiplying those out will give us numerically the same value, different units, 8.66 newtons, and I'm done with my answer. So I put a box around it to show that I'm done.